Okay, today we're going to cover linear transformation. So this is going to be, I believe this is notes number 4. It was supposed to be notes number 5, so it got switched. But today we're going to do linear transformations. So transformations it's basically stating what change happened compared to our parent function. So we're going to go over our parent function, and then we're going to talk about how that function, so that line would either be shifted up or down on the graph, whether it starts going down versus up, and whether it gets steeper or less steep. So all of those are transformations that could occur that basically change our equation somehow. So our parent function equation is y equals x. So anything that is added or subtracted to this equation is what is going to create a transformation. So we have our x and our y table, -2, -1, 0, 1, 2, and then our numbers are the exact same for our y. So we're going to plot these points. Then we're going to draw our line in between our points, if I can draw a line. So that is our function. So if you guys remember, this is a linear function. Our domain, if you guys remember, that's all the x values our line is going to hit. So this is going to hit every x value because it's going on forever. So it's all real numbers. Your range is your y value, and it's going to hit every single y value because it's going to continue going up and down. So your range is also all real numbers. Now your x and y intercept, where it crosses the x-axis, they both happen to be at 0, 0. So those are our parent functions. So any change that happens to this line, whether it's shifted up, so let's say it has a y-intercept of 2 now, or if it's shifted down, it has a y-intercept of -1, those are going to be transformations that occur. So our first transformation is a vertical translation. I just want you guys to know, is it a shift up or a shift down? So this is when our b value, so in our y equals mx plus b, our b value there's an added or subtracted number. So if a positive number is added, the function is shifted up. And then if a negative number is added, the function is shifted down. So the first one we have y equals x plus 4. So this plus 4, what does that mean? That means it was shifted up by 4. So we're gonna say shift up by 4. So if we were to, our parent function is going to be this dashed line. If it was shifted up 4, that means it would be at a y, it would have a y-intercept of about 4. Our next one, we have y equals x minus 5. So the minus 5 means it was, this a shift down by 5. So our parent function, I'm again going to draw as a dashed line, is this. If it was shifted down 5, that means it would be somewhere down here. These are just sketches, so they don't have to be perfect. So that is our vertical translation of shifting up or shifting down. Now let's talk about our other value. The other value, so this one, with our shift up or shift down, we talked about our b value, which is our y-intercept. Now we're going to talk about our m value. So the first thing that we look at is our m value positive or negative. If it is negative, there is a reflection over the x-axis. This changes the parent function from increasing to decreasing. So if our m value, if our slope is negative, there is a reflection over the x-axis. So this one has a negative slope. So what happens is there was a reflection over the x-axis. So our parent function normally goes up, correct? If it's reflected, it is now going to go down. So that would be our new function. Okay. Next, after we look at is our M value positive or negative, we then look at what is our M value. Depending on what our M value is, depends on if it's a vertical stretch or compression. So if your M value is greater than 1, it's going to be a vertical stretch. So if it's a vertical stretch, that means it got stretched out, so it got steeper. So this one, we have an M value of 2. So that means a vertical stretch by 2. So our parent function looks like this, right? If it was stretched, that means it becomes a little bit steeper. And this one has a M value of 5. So this means it was vertical stretch by 5. So again, if this is our parent function, if it's 5, it's even going to be steeper than the other one. It's going to probably start like this and just go up. So if your M value is bigger than 1, it's going to be a vertical stretch. Now, if your M value is less than 1, then it's going to be a vertical compression. So a compression means it was compressed, so it was smushed down. So this is where your slope is less steep. So on this one, our slope is 2/3. That is less than 1. So we would say vertical compression by 2/3. So if this is our parent function, if it was compressed, that means it got flattened out a little bit. So it looked like this. So on the other one, we have an M value of 1/2 or 1/5, sorry. So this means a vertical compression by 1/5. So if this is our parent function and it was compressed 1/5, that means it's either going to be less steep than the first one. So it's going to be something like this. Okay, let me know if you guys have any. Actually, I want to do a couple other I want to kind of sum all this up together. So I really don't have any room to write. We're just going to zoom in. So if you guys have a blank scratch or paper, you can do this on your homework. So let's say I have y equals negative 2x plus 6. So with this, I look at my negative first. That means there's a reflection over the x-axis. Then I look at my M value. It's bigger than 1, so it's a vertical stretch. And then I look at my B value. It's plus 6. So this means it is shift up by 6. So that's how we're really going to be applying it. So let's give another example. Oh, I don't have much room over here. So let's say I have y equals 1/3 x minus 2. This one doesn't have a negative, so there's no reflection. So then I look at my M value. It's 1/3, so that means a vertical compression by 1/3. And then the negative 2 means there's a shift down by 2. So that is how we're going to be applying it whenever we're talking about that. So if you guys can find a couple little space to do those examples. Okay, you guys can get started on the homework. If you guys have any questions, please let us know.